A, we will do that, yes. But you don't have to holler at me. So yeah, I'm not going to, the solutions are all up on Blackboard as far as that goes. So we'll do 13, 13.8, 13.9A. It would make a difference as far as my solutions are concerned. 13.9A. So that's this one on the left. All right, so we do need to do is sum the forces in the y, though, don't we? We need to find out what AY and BY are. Okay, so we've got sum of the forces in the y, 0. We've got AY plus BY minus. I work okay under pressure, but not fast. Minus something. Well, let's see. There's a force that's pushing right here, isn't there? It's a third of the way over, right? So a third of 20 is 6.67. All right? And it's 10 kips per foot over 20 feet. That's, what's that, 200? Yeah. Divided by 2 because it's a triangle, right? So you're looking at 100 kips at 6.67. So, but in this case, it's 100 kips. Sum the moment at A. We had 100 kips. Let's try and make it go clockwise, which is negative, times 6.67. Plus BY at 20 feet. BY equals 33.35 kips. Up, of course. 33.35. AY is 66 something, isn't it? Yeah. 66.65 kips up. Okay, now when I draw my free body diagram of that at 5 feet, I think is what it was, wasn't it? Yeah, it's supposed to be, or 10 feet, I'm sorry. It's supposed to be in half, right? So if we draw a free body diagram, look at that. I'll even draw you a real nice straight line this time. Got lucky. This is 66.65. Okay, then we know we've got that 100 pounds out there, right? But it's a little bit different now. See, it's a little bit different. What we're going to do is let's draw in that unevenly distributed load, and that would be like way out here, wouldn't it? I'm gonna have to erase some of this. I'm gonna draw it like this. This is what the triangle looked like originally, right? Actually, it's better than that. But we're only dealing with 10 feet of it. So what you're going to do then is you're going to take this and say, okay, I've got 5 kips per foot for this whole length. Okay? So that's one force that's hanging down right here, which would be 50 kips, right? You can break this up. That's over the whole thing. Then you've got another force here that's coming down this way. Doesn't matter where you put it. And this whole thing was 10, right? Up to here was 10. Over to here is 5. 10 kips per foot, 5 kips per foot. And the reason that's because you cut it right in half. So you know that halfway through that line it's 5 kips. That's why it's critical that they said cut this in half. So you could tell that was 5. It's a relationship thing there, isn't it? Okay? So anywhere you cut that along that line, you would have to go with that relationship. So if you went 3/4 of the way out, then you'd be 3/4 of the way here. So it'd be 7.5.
Yeah. 5 times.
So it's 5 times. Oh, let's see, 5 times. It's 5 kips per foot, but it's 10 feet out to there. So it's 50 kips. Well, this one would be 5 times 10 divided by 2, right? Because it's a triangle. So this one's 25 kips. And now where's that located? Well, this is 10, so it's 1/3 of 10, right? 3.33. And this one is 5, right? That's the only trick to this problem. Now, for some reason, he had this still at 50. He said, well, it's 10 divided by, or it's 10 times 10 divided by 2.
So he forgot
But you already took half of it right here.
Yeah.
So this if you're representing this triangle right here, it's only half of this 5 times 10 divided by 2. Well, I said half of it. Okay. Jabril?
How could you get to 5 feet?
Because it's cut right in half. This thing extends out 10. So you're going from here, you're going half of that is 5, half of that height.
So it would be.
I'm talking about the separation for the 50 feet.
The separation for what?
The location of the 50 feet.
Of the 50 kips?
Yeah.
Oh, well, this distance from here to here is 10. So halfway, that's that concentrated load, right? For a rectangle. For the triangle, it has to be 1/3. Yeah.
So is it safe to assume that if we had to figure the other side, if we had to look at it from the, the rest of that triangle would be 25 kips also? Because you would just have to do the same amount as you would, yeah. So if we had to look at that side for some reason, we could assume that too.
Yep. Yeah, because you could cut this and look to the left or the right, right?
Yeah.
Fair enough. So our shear then, what do we got? We got 66.65 minus 12, I wanted to say 12, 25 minus 50. That comes out to a negative value, doesn't it? Oh, no, it doesn't. 4.5. 4.5 kips. It came out a positive value, so the shear, internal shear is going down.
It'd be 4.45 or 35.
I get a negative 8.3.
I didn't
Yeah.
get what it should be a negative value because this is 75. I don't know where my math came from. Maybe I did. Did I? No, I don't think I looked at his number. I don't know. It should have been negative because that's 75 minus that.
Yeah.
So what was it? Negative what?
8.35.
So it's negative. So it's 8.35 going up. The internal shear. Okay. The moment. Let's move that up a little bit, maybe, huh? Except for then we can't see the picture. Okay, so the moment then, looking at it from that right side, right? Come on. So we got 50 kips going down, so that's minus 50. That's 5 feet, right? Minus 25 at, what's that, 6.67? Yeah. Plus 66.65 times 10. Do the math on that. Hopefully it's 333.13 kips feet counterclockwise. But the trick was just breaking that out into those two shapes. That's the biggest.
So the only thing you would have gotten the same number if you would have just done 50 kips for the top triangle, kind of. You're saying that's what he did. He made his mistake in the book.
Yeah, he made that 25 actually 50,
50, yeah,
but you can't do that.
yeah,
If you break it out, you have to break those out.
yeah.
Yeah, I'm getting 249.75.
Oh, for that moment? Somebody check that. I don't have my calculator. What?
249.75.
249? So, how did I screw that up?
Did you work for Malaysia Airlines or something?
Yeah, that just aggravates the crap out of me too. They're saying, well, we've got 35-year-old technology. Well, whose fault's that? Yeah, they've been charging the crap out of your fees, haven't they?
Yeah, why don't we have 35-year-old prices?
Exactly. What was the number again?
249.75.
It still was positive though, right?
Yes.
And that's Kip's feet. Comes out in that direction. I need to write that. I need to circle those at least, don't I? So that I can go back and change those. Sorry about that. I don't know where I came up. I wonder if I looked at his answers by chance. No? Oh, you know what though? His answers in the book are right. His answers are right, but that 25, wait a minute.
It's definitely 249.75.
Oh, that number is not, that 25 is not right. Sorry. Wait a minute. 10 kips per foot. It's 5 kips per foot. Yeah, that number is not 25. But wait a minute. 5 kips per foot times 10 feet. Yeah, divide. That is 25.
Yeah.
Those numbers are right. I don't know what I was. Yeah. Okay, we're good. But just remember that triangle. You have to break that up. Okay. What else? Anything else? All right. Real quick on the free body or the shear diagrams. We may not. I can't go real quick. That's not going to happen. We'll probably be pushed back to Friday. Sorry. But I think we better, I got to show you this. I can't just jump in 5 minutes, be done. It ain't going to happen. So Monday we'll go over the rest of this chapter, and then I'll give you some problems to do.
It's okay, we'll be more prepared on Friday.
Yeah, I think, I don't want to, I'm not going to do that. Okay, so let's call it quits for today. We'll come back Monday. You don't have to do any homework over the weekend, I guess. And we'll come back Monday and talk about shear diagrams and moment diagrams. Give you some homework. We'll go over it Wednesday. And then you'll have Friday to take the test. Actually, I guess what we could do on that, if you wanted to come in early, like on Thursday, if you don't have anything going on, and you wanted to come into one of my other classes and take it, you could. So I don't have a problem with that. Do what? Friday's okay. I mean, but I'm just saying, if you don't want to have to come in Friday, I can give you the test in one of I've got a class in room 220 on Thursday from 10 until 12:30, and I've got a class in room 223 from 1:30 to 4 on Thursday next week. And we can talk about that as we go into next week. Do what?
Are they both CAD?
Yeah, they're both CAD classes, and in the and potentially the one on Thursday morning, there might not even be anybody there. So I may back off on that one, because if everybody gets their projects done, they won't be there. So we'll keep you posted.